Today we're going to talk about methods or calculations of dispersion. In our last video, we talked about measures of central tendency, which, if you've got a collection of data, means we're looking for the numbers towards the middle, which were the mean, the median, the mode, and the mid-range, which is really helpful to understand what's going on, especially if you have multiple bits of that information. You've got both the mean and the median. Now you understand a little more about the data. However, you should also take a look at how dispersed the data are. Is it a collection of data points all centered around a center point such that it doesn't spread out very much, or do they spread out pretty far? And so that's what we're going to look at today, is how spread out they are. Think, for example, of seeing a chart. That's not a great curve, but let's assume those are straight lines. And maybe the data come across and they peak like that if we graph these, which is fine. Some data do that, and other times they come up like this and down. Notice they would have the same mean and mode right here in the middle, but the blue graph is definitely more spread out than the red graph. So that's what we're looking at today. Specifically, we're going to look at range and standard deviation. So range is specifically how wide are the data. So we take the largest number and we subtract from that the smallest value. That's it. What is the difference between the largest and the smallest data point? So with the red graph, maybe there to there would be the range, and the blue graph maybe there to there. We can see the range on the blue graph is much larger, so the data are definitely spread out a bit more. Standard deviation is a way for us to measure how clumped the data are together. For example, this red graph, you might get 70% of the population within those two vertical lines. With the blue graph, it might have to be out here at these vertical lines. And so we've got a definite spreading of the data with the blue graph. And we saw that with range alone, but standard deviation helps us break the data into very measurable chunks or groups. Groups sounds more technical, I'll use that one. And it will allow us to then see, next week we'll use standard deviation, for example, to figure out when we have 68% of the population or 95% of the population. And we'll concentrate a little bit more on what's called the normal curve and break that up. I did want to show in your formula sheet, we have, excuse me, a sheet that shows some of the calculations that we did a week or so ago with factorials, permutations, combinations, and so on. And below that, we have a box that's called statistics. And specifically, this shows us the 6 steps needed to calculate standard deviation. First, we'll need to find the mean of the data items. Then we'll find the deviation of each data item from the mean, meaning we just subtract the mean from each data item. Notice they have put the calculation here for us so that we could, I think maybe I can draw on this. They put the calculation there for us, and that's the calculation we'll be doing. Then we need to square each of those deviations. Then we'll add all of those squared terms together. Then we'll divide that sum by n minus 1, where n is the number of data items. And then we'll take the square root of that quotient. And all of that together will allow us to calculate standard deviation. So in this section, we're really just calculating it. Next week, we will use it a bit more. But again, I want to point that out so that we can make some calculations. Let's go ahead and do that calculation a couple of times. And that will allow us to practice it and get a good sense for what we need to do. So our first step was to calculate the mean. And the mean, if you'll recall, we denoted with X with a bar over it. And we found that by adding all of our data terms or data items together, and then dividing by the number of data items. So for sample A, we're going to sum the numbers from 17 to 23 and divide that by 7 because there are 7 data items. So when we add all of that together and divide by 7, we get 20. Now let's, while we're at it, find the mean of sample B. Using the same method, we'll just sum all of those data items and divide by the number of data items. We still have 7 data items. And when we do that sum and then division, we also get 20. So these two data sets have the exact same mean. And that's why hearing, oh, the mean is 20, only tells you so much. If we look, for example, at the range of these two, we'll take the largest item and subtract from it the smallest item. And we see we have a range of 6 for sample A. And for sample B, we have a range of 30. And that tells us right there that we have quite a difference in our data sets. And that's important for us to note when we're looking at data. So our first step was to calculate the mean. Now I'm going to concentrate on sample A for a while, and then I'll go back to sample B. I just wanted to start by looking at the mean of each data set. Step 2, and let me go back to the formula sheet. Step 2 was to find the deviation of each data item from the mean. So we take each data item and subtract the mean from it. So I'm going to go ahead and list the data items here. That seems to me to be the best organization for working this out. You may have a different system that works for you, and that's great. Find the one that works best for you and run with it. As long as it's working, let's use it. So we've got these data items. We're going to subtract the mean from each one, and we fully expect to get some negatives. That would be appropriate, as some numbers have to be below the mean, unless it's a collection of all the same number. And some would have to be above, so we'll have some positives and some negatives. Now, I think in the homework, they ask you at this point to sum those. And when you do, you find out you get 0, which proves that there's not much we can do by summing those. It doesn't help us too much, but it's just an exercise to point that out. So that was step 2, was to find the deviations. Step 3 says to square each deviation. So now we'll take each of those terms and square them. Now notice I'm writing the -3, -2, -1 in parentheses because we have to square the negative. Remember on your calculator, back in chapter 8, sometimes we had to square a negative, and if you just write -3 squared, sometimes it squares the 3 and then applies the negative. But if I put the whole thing in parentheses, now I'm squaring the negative as well. And a negative times a negative is a positive. So -3 times -3 is a positive 9. -2 times -2 is a positive 4. And so on. And so watch for that. Remember, we ran into that trouble in chapter 8. But that means we should know what we're doing now with our calculators. So that was step 3. And let's take a look at step 4. Step 4 is to sum those squares. So now we need to add all those square terms together. So I have 9 and 1 are 10. 9 and 1 are 10. So that's 2 10s and then 2 4s, which is 8. 2 10s is 20 and an 8 is 28. And I just do it that way to show you that you don't have to add one right after the other. Sometimes you can do it faster if you look for ways to speed it up. I see that 9 and 1 are 10, and it's easy for me to add 10s, just like it's easy for you to add 10s. And so doing that, looking for those tricks can speed up your math just a minute. All right, now we've summed those squares. And now step 5 is to divide that sum by n minus 1. So we need to take 28 and divide it by 7 minus 1, because 7 is the number of data items we have. And so now I need to divide 28 by 6. And when I do, I get 4.6666. So I'll write 4.67, but in my calculator, I'm going to keep all the 6's. That was step 5. Remember, it's a 6-step process, so we're almost done. Step 6 says to take the square root of that quotient. So now the standard deviation, which we denote with an S with a little X next to it, would be the square root of that 4.6. I'll go ahead and put another 6 in there. But now what I'm going to do is the square root of my previous answer. Remember, I think we talked about that ANS option that's down often by the enter key. That's the previous answer. So that's remembering the 4.66666. So when I take the square root of that, I'm not rounding anything. And I get 2.16. That's our standard deviation. Oh, I should also mention, let me come back here to this slide. The notation for standard deviation, and I just told you we're going to use S sub x. That is the standard deviation of a sample, which is what we are doing in this class. Sometimes you'll see this little sigma. Remember, we had uppercase sigma, which meant sum of, when we're adding things together. This is lowercase sigma, and that is the standard deviation of an entire population. And we will not be using that in this class. We will be using the S sub x. The difference is when you do that division by n minus 1, with the population, you just divide by n. But the one we're doing, we will be dividing by n minus 1. So that's the standard deviation of a sample. I did want to point that out because I'm going to show you in a minute how we can do this same calculation in a calculator. But that's our standard deviation for this particular data set. And that is step number 6. So it's a little long, a little tedious, but the math is not difficult. It's stuff that we've been doing. It's really arithmetic, adding and dividing, squaring. There's nothing fancy about this, but let's go ahead and calculate the standard deviation of sample B. We've already done step 1 where we find the mean. Now we need to do step 2 where we subtract the mean from each data item. They call that the deviation. So we're going to find these deviations. We'll subtract 20 from each one. 5 minus 20 is negative 15. 10 minus 20 is negative 10. 15 minus 20 is negative 5. And so on. And once again, we find that if we were to sum these deviations, we would get 0. So that was step 2. Step 3 says we need to square those deviations. Once again, I'm going to put the negative in parentheses to make sure the negative gets squared too, not just the number. And negative 15 times negative 15 is 225. Negative 10 squared is 100. Negative 5 squared is 25. 0 squared is 0. And then we're going to go back up since those are the same. Now that won't always be the case. Sometimes your values are such that they don't perfectly mirror each other, but that's fine. We can still write those all out. They will still follow our procedure well. So that was step 3. Step 4 is to add those together. 225 plus 225 is 450 plus a couple of hundreds. So that was 450. Then we had a couple of hundreds, which was 200. And then a couple of 25s, which were 50. 450 plus 200 is 650, plus another 50 is 700. Again, just a quick way to figure out how to do that in your head. We've got calculators. We can do that just fine. That's not a problem. You don't have to do it in your head, but sometimes it's just kind of nice to be able to do so. So now we have 700 divided by 6, which is 116.666. That was step 5. And now step 6, we take the square root of that. And again, I'm going to use what's already there. I'm just going to get the square root of ANS, and it gives me the square root of the last thing I had in there. I didn't hit clear. I don't want to clear that. I want to keep it in the memory. And I get 10.8. So the standard deviation of sample B is 10.8, and that of sample A is 2.16. Clear difference. Standard deviation is, again, how far things are spread out. We can see that just by looking at the samples and looking at the range, that the data are definitely more spread out in sample B than they are sample A. And so we already knew the standard deviation would be larger. But interestingly enough, and we'll get to this next week as well, all of the data within one standard deviation, either above or below the mean, is considered normal. And that encapsulates about 68% of the population on that one category. So almost 70% of the population is normal for any given characteristic. That would suggest that very few of us are really abnormal in most of our characteristics. We may have some that put us beyond that range, but the reality is most of us are normal. I've seen teenagers many times talk about how wonderful they are to be abnormal. And I think, well, you're probably within the 70% group. I mean, that's the vast majority of the people you run into are absolutely normal. But it's a weird time. And so it feels odd, and you feel odd. And so you feel like you're abnormal, but the reality is most of us just fit. We fit rather well. Okay, let's take a look at a few more things that we have to talk about. That is basically section 12.2, but I also wanted to share a couple of things with you. And that was back here in section 12.1, when we were looking at these data, we've got 30 data points, for example, and we needed to make a frequency curve. And I, in my last video, said, oh, I want to show you something in the homework to make it easier. And then I forgot, but I've remembered. And so I want to show that to you. And it's this icon here. If I click this icon next to the data, it says I can open these data points in another software package, say Excel. It downloads a copy of the data to your hard drive, which you can then open in Excel. And the reason this is helpful, and I'll show you here in a bit, is that now we can arrange the data in numerical order. And it's far easier to count how many 15s we have, for example. Well, I probably should have opened Excel beforehand so it didn't have to go through this startup. Just the same, we should be okay. So here are the data, and I'd have to click Enable Editing so I get everything I want. But notice I've got the top cell selected, and I'm going to come over here towards the right and choose Sort and Filter. And I'm going to sort smallest to largest. Now I saw one student did this and it opened it in a web version. And that works fine, but this sort button wasn't over here. They had, notice next to the sort smallest to largest, it's got A with a Z below it and an arrow down. They had that button. And so we knew that that was the button we needed. So now that I've clicked that though, look at the data. It's completely organized in numerical order. So if I bring my browser back up and don't have it maximized, now I can quickly see I have 3 15s. I have 3 16s. And also note this, I'm going to highlight, let's highlight 17. Say I don't want to count it. Down here at the bottom, it tells me there's a count of 4 items. It even tells me what their average is and what they sum to. So if I were to select the whole data set, I can see at the bottom that there's a count of 30, and the average, which is really a mean, is 19.77. And so with Excel, you can very quickly find some of this information. I use it mostly to get it organized so that now I can quickly type in, oh, I have 3 15s. That's the frequency of that particular number. 16, it looks like I have 3 16s. Being in numerical order, it's much easier to see that. Now, I also want to show you another, and that is open in StatCrunch. We all have StatCrunch built into my lab, so it should open for every one of us. And again, it will bring up the data, and if we want to, we can sort the data. I've gone to the data menu and I can click sort. You have to tell it which column you're looking at. And we're going to sort variable 1 and make it ascending. And when we do that, it puts it in numerical order. But now I'd also like to calculate the mean, maybe. And it always takes me a minute to remember what I'm looking for. But I think I want summary stats columns. I want variable 1. And I'm going to group by variable 1. And notice it's got n, the number of items. It's got the mean. It's got standard deviation. Now when I hit compute, oh, it gave me each one. There's another one. Let me find it. Oh, I was sure that was it. Maybe I don't want to select variable 1 and group by. That's not. Okay, don't select variable 1. Now I have 30 items. The mean is 19.77. The standard deviation is 3.14. The median is 20. The range is 10. Gives me the minimum and the maximum. All of that is there. Now, I'm not sure whether that standard deviation is of a sample or of the entire population. So be careful using that one. But being able to open this in StatCrunch is helpful. And I've made it so that will be available to you. So that's a tool that you can use on the 12.1 homework that I forgot to mention before. Let's go back. I wanted to go to my data set. That's where I wanted to look. So I've got my data set here, and we went through this process of calculating standard deviation. But remember, I've shown you a couple of steps on this calculator, and I want to show you some more now. we looked at data and we put data into our calculators and then had it calculate the mean and the median. And remember, standard deviation was there, but I said we would talk about it later. So now I'm going to show you again how to use that. I'm going to use sample A, where we had data note items 17 through 23. And remember, I just clicked the data button to get to here. And also, your calculator may not look like this, but it may very well have a way to enter data and get mean, median, and standard deviation. So consider that. I wish I had an emulator for all of them and I could show you on all of them. But there's often a data and a stats option. Now remember, the stat is right above the data button, so I need to hit the second button first. And then when I hit data, it will ask me for the stats. I want one variable statistics. The data are in list 1, since that's where I put it. The frequency is 1. There's only one of each. And so I'm going to hit enter on each of those and then hit calc. Gives me the number of numbers is 7, and we already knew that. Gives me the mean. Again, it's 20. We had already calculated that. And there's the standard deviation, 2.16, which is the exact same thing we ended up with when we calculated it by hand. So having this in your calculator can speed up your work. If you mistype one of the data items, then you're in a bit of a pickle. But you've got this tool available to use on the homework or and to speed things up. Now notice here's the standard deviation of a population, where instead of dividing by 7 minus 1, they divided by 7. And so it's different, and we won't use this one in our homework. Not that sigma, we'll use the S sub x. And as a reminder, it's got the sum of the numbers, the sum of the numbers squared, and so on. It's got the median down here, 20. But you've got your calculator to help you. And I did want to show you that sometimes that is available. I'm going to hit the data button twice now, and it gives me the option to clear list 1. So it's clear and available for my next assignment. But that's how we look at some of the dispersion of our data so that we better understand the data set. Next week, we'll talk about how to use standard deviation a bit more to do some calculations so that we can compare data items. Say, is this score a good score? It gives me a grade, but how does that compare to the other scores in the class? Knowing mean lets me know if I'm above or below the mean, but we know the mean isn't necessarily right in the middle. The median tells me if I'm in the top half or the bottom half. Standard deviation tells me, did everybody score about the same? Or did some people score really low and some really high, and we're just somewhere in the middle? So it gives you more understanding of how things are. I hope this helped, and let me know if you've got questions.